In this video, we're going to talk about using Excel for one sample means testing. This assignment uses the cloud-based online Excel 365, not the desktop version. The assignment file, if you're interested, is in the link below. Also, for BHCC students, this is on Moodle. Remember that these are supplemental videos and exercises to use Excel for an Introduction to Stats course. The purpose of assignment 11 is to perform one sample hypothesis test on a mean in Excel. Our objectives are to do one sample means testing with the p-value method and then with the confidence interval method. A one sample means test is used to determine if the mean of a single sample is significantly different from a known population mean. Your data setup should consist of your quantitative data being in a single column in Excel. The data can be discrete or continuous, but it should be quantitative data. The first thing you want to do when you're doing a hypothesis test is define what your claim population mean is. So you have to decide on the null hypothesized mean that you're going to be testing and comparing against. It's a good idea to enter this value in a separate cell in Excel for reference. The formal method to do a one sample means test consists of calculating a test statistic and then using its associated p-value to determine the test result. So in Excel, what we need to do is to do some interim calculations in order to get there. One, from the data, we want to calculate the sample mean. Second, we want to calculate the sample standard deviation. Third, we like to have the sample size. Fourth, we're going to calculate the test statistic. Now, this is the value of most importance. What a test statistic is doing, in this case, you have the sample mean minus the hypothesized mean divided what's called the standard error, which is the sample standard deviation divided by the square root of n. This value here is a t statistic that we're going to get the associated p-value from, and that's going to determine the results of our hypothesis test. Okay. In order to do that, because we're using a t, not a normal distribution, we need what's called the degrees of freedom, which is simply the sample size minus 1. And this right here is the Excel formula of utmost importance, because what this is going to do, we're going to first calculate this t statistic sort of manually, just calculating the sample mean minus the null hypothesized mean divided by the standard deviation divided by the square root of the sample size. We're going to get that from having all these values ready. Okay. Then this value here is what we're going to use in Excel, and we're going to get by taking the absolute value of the t statistic and the degrees of freedom. This is going to give us a p-value that is going to give us the determination for our test. And so the p-value method involves if p is less than 0.05, we reject the null hypothesis. And then our test indicates that our data is significantly different from the population mean. Otherwise, if our p-value is greater than 0.05, we do not reject the null hypothesis because our data are not significantly different from the mean. Okay. And what we're doing when we do a t statistic essentially is we're looking at the difference between the mean and the null hypothesis and adjusting it for the standard deviation and sample size. So let's go into Excel and see how this is done. I'm now in Excel 10, which has 2 blue tabs, and then it has 3 yellow tabs, because the second yellow tab is for you to actually run the same test in 2 different ways. But right now I'm going to go over the first blue tab. And so here's my data. It's data on weights. And I want to test the hypothesis that the mean weight of a soccer player is 80 kilograms, and also that the mean weight of a soccer player is 70 kilograms. So there's actually 2 tests to run here. The first thing I want to do is have some basic information ready. So I want to have my mean, my standard deviation, my sample size, and those I'm just going to use Excel calculations for. Okay, so I'm just going to get my that, and then I also want to have my null hypothesized mean that I'm going to do for each section. So my overall, just using the data and doing the summaries here, my mean is going to be my average. Okay. And that's going to be the average of this column here, my weight average, 74.1. And then I'm going to get my standard deviation, which I'm going to use my Excel formula for. Okay. That's going to be my sample standard deviation formula as always. There we go. Next, I'm going to get my sample size. I'm going to use function count because I'm too lazy to scroll to the bottom and look at how many there are. And so that's 30. So this is just my basic data information that I need. Next, I'm going to run two different hypothesis tests. The first one says test the mean weight of the soccer player being 80 kilograms. So this one I'm going to write null and I'm going to write 80 just to have that for reference. Next, I'm going to calculate my test statistic. Okay. That is this value here. Okay. So that's going to be my mean minus my null divided by my standard deviation divided by the square root of n. I have all that. It looks a little complicated, but it's not. And I can even just, I could just copy this if I wanted to do it directly, but I'm just going to do it by using the values that I have. So it's going to be the mean minus the null hypothesized value divided by the standard deviation divided by the square root of n. And we have all that. So that's just going to be this equals, and it's going to be this. I'm going to put the top in parentheses just for a little bit of organization. Okay. That's the mean, the data mean minus the null hypothesized mean. Then I'm going to divide that by, on the bottom, I'm going to have the standard deviation and then divided by the square root SQRT of the sample size, which is here. Okay. And then I'm going to close this and hit go. Hopefully. I think I need one more parenthesis. And so my test statistic is -5, which is really, really big. Let me just double check that because it looks suspiciously huge. No, I think that might actually be right. Okay, so that is in fact definitely the right value. I went and double checked it. So we have a test statistic of -0.5, or -5 rather. That, knowing the normal distribution and the t-distribution is very, very close, that is totally outside of the 95% region, which is, 95% of a normal curve is between 2 and -2, and so -5 is way out on the extreme. So just based on looking at that test statistic, we pretty much know that our test is going to be significant. But we also want to go ahead and get the p-value. Now, the p-value in this case, we're just going to basically get 0, but let's run it anyways. So the p-value in this case, we're going to do equals, and then we're going to run t distribution two-tailed. We're going to run this function here, t distribution two-tailed, and this is, I probably shouldn't try to flip screens when I'm doing this, but this is the same thing as this. So this function here is what we're going to run, and it's going to give us the p-value associated with that test statistic. Okay. So we're going to go in here, and we're going to do t-dist 2t returns two-tailed, and it says x degree of freedom. So all we need is x. That's going to be the test statistic. And then the degrees of freedom is going to be n minus 1. N is 30 in this case. So it's just going to be 30 minus 1, which I could have just typed in 29. And so this is going to give us our p-value, which is going to be very, very, very small. So I'm not sure whether it's giving me this because it's too small or because there's a problem with the number used. So let's try this. D8 is the test statistic. Maybe I did it backwards. X is the numeric value upon which to evaluate the, no, that's the test statistic. That's right. And then let's type in 29 because it doesn't seem to like understand that. Okay. And okay, so I think I figured out. That's because I'm not following my own advice. It's only going to take an absolute value. So we need to do abs, and then we need to put the t statistic in the absolute value. That's the issue. And then 29 is the degrees of freedom. And then hit go. And then we get this value here, which is 2.47 times 10 to the minus 5. This is just, it's basically 0 times 10 to the minus 5 is like 0.1, 2, 3, 4, 5, like really, really small. So the p-value, we would also say that it's less than, it's certainly less than 0.05. It's actually less than like 0.01. So the conclusion here is going to be that our data do not support the null hypothesis of the age or the weight being 80. Even though 74 is not super off, the standard deviation is not super big and the sample size is relatively large, not huge, but the data show that the mean from the sample is significantly different from the null hypothesized mean of 80. And that's what we just did when we ran that test. Okay, so I'm going to run one more of these this way, and it's to test the hypothesis that the weight is now 70. So basically everything's the same, except now my null is going to be 70. So now I'm testing against the average mean from the population being 70, and I'm going to get a different test statistic. Same formula, but I'm now going to enter instead. My numerator is going to be my sample mean of 74 minus, in this case, 70. Okay. And then I'm going to divide that by parentheses, my standard deviation, and then divided by the square root of the sample size. And that will give me 3.5. Now 3.5 is going to give me a small p-value too, but it's not as extreme. So this is not going to be supported by the data either, but it's a little bit not as egregiously off as this. Probably like 75, if I tested against that, I would not get a significant result. But let's just go ahead and calculate the p-value, even though we know it's basically going to be 0. And this is going to be equal to, again, t this two-tailed absolute value. In this case, it wouldn't have thrown an error because it's positive, but I'm going to do it anyways. And then 29 is our 30 minus 1. That's our degrees of freedom. And then this is going to give us a p-value of 0.001. That's still going to be less than 0.05. So once again, we conclude that our sample does not support our null hypothesized mean of 70. Okay. That's what I just did when I ran this test and interpret the p-value method. Now, there's another way to do this that I actually kind of like a little bit more, especially for this level intro course. And that is to just look at a confidence interval. And confidence intervals we did in the previous assignment and how to do those in Excel. So in this case, what you do is a confidence interval for the data and for the mean in the data. And then you just look whether or not your hypothesized value is in that interval or not. If your hypothesized value contains the interval, then basically we fail to reject the null hypothesis, because what we're saying is that if the null hypothesized value is in that interval, it's very reasonable that the null hypothesized value is supported by the data. Otherwise, if the hypothesized value is not in the interval, we reject the claim and conclude there's a significant difference. And that corresponds with a p-value less than 0.05 that we just saw in the example. But let's go ahead and run this in Excel with the confidence interval method. Okay. So the confidence interval method is here, and it's actually the same data and same test. Oh, actually, no, this one's against 75, so it's a little different. It's the same data, and so I can just actually kind of cheat a little bit. It's going to be the same data, so I'm just going to copy the summary values that I have. Oh, is this height or weight? Wait a minute. No, it is weight. We're good. It's the same data. Okay. So I'm going to just do a paste special. I always do that when I copy those. Okay. So now what I want to do is I'm going to test the mean, but I'm going to test the mean by doing a confidence interval. Okay. So we already have the mean. We don't want that. We want to have the standard error is what we want to have. I mean, the margin of error, sorry. So this actually goes back to the previous Excel. Okay. So I'm going to show something from the previous Excel. This is from assignment 10. So what we want to use to get our margin of error, because the confidence interval is going to be the mean plus or minus the margin of error. So we're going to use this formula confidence.t to get our margin of error, okay? And then we're going to add and subtract that to our sample mean. So I just want to point that out. That's in a prior assignment. Okay. Okay. So what we want to get here is our margin of error. Okay. Make this a little bigger. I don't know why it's doing that. Okay. Made a little table for me that I did not want. Thanks, Excel. Okay. So our margin of error, we're going to use a formula, but it came from the previous assignment. So this is going to equal confidence T, okay? And then we're going to enter alpha, which is going to be 0.05 because we're doing a 95% test. And then we're going to enter the standard deviation that we have here. And then we're going to enter the sample size that we have here. Okay. And so our margin of error is 2.3. And what we're going to do to get our confidence interval is we're going to go lower, upper, and the confidence interval is just going to be the mean plus and minus this. So it's going to equal this minus the margin of error, which is here. And then it's going to equal that plus the margin of error. Okay. Now, this is our interval, 71.7 to 76.5, essentially telling us that that is where 95% of the data is. 19 out of 20 times the true mean would be in an interval like this at the 95% level. Is 80 in there? No. So because 80, which is our null hypothesized value, is not, we reject the null hypothesis that the mean. Okay. So because when we do the hypothesis being 80, we're saying that that's the population mean, but this is what we get from the data, 71.7 to 76.5. So basically, given this data, it's not realistic that the mean is actually 80. Okay. So then I did this one. This one is actually a different number than the previous because the other one I did 70. This one I'm doing 75. So let's do a confidence. Well, we don't actually have to do another confidence interval, by the way. It's just part of the beauty of this is the confidence interval. It's from this data. So to test the mean that the weight is 75, 75 is within this. So if we use the confidence interval method of like hypothesis testing, which is a little less formal than the actual p-value method. Like you really should learn the p-value method and how to do it. It's actually easier really though to do confidence intervals and just look at like whether they contain the mean. So to run this test, we just look at the interval that we already have because it's going to be the same interval. It's the same data and stuff. So in this case, we're testing against 75. Now 75 is within this interval because 75 is within the 95% confidence interval. We fail to reject the null hypothesis that the true mean, population mean, is 75. So it's very possible, given this data does support that the population mean, the average weight could be 75, and that's very reasonable. And that's how you interpret things with the confidence interval method, which is a slightly easier way to work. Okay. And that's it. That's not so bad. P-value method is more formal. Confidence method is easier to work with. And so that for you, now I have for you a p-value method test to run, a confidence method test to run, and then I have for you also one more that does the same test and compares both, just to give you a little bit more work to do. Okay? Thanks.